How China will build a permanent base on the moon. China has officially announced that it will achieve manned lunar landing before 2030 and begin building a permanent lunar base. Although the specific landing site is still under scientific evaluation, the surrounding area of lunar lava tube caves has become one of the key candidate targets. Scientists believe that these pits are actually collapsed parts of ancient lava chambers. Scientists have discovered through high-resolution imaging technology that many pits have tunnel branches at the bottom, especially in the Tranquil Sea and Marius Hill areas. To confirm whether these tunnels are hollow, NASA's Holy Grail mission also confirmed the existence of these underground voids through gravitational field data. These findings indicate that there are vast unknown landscapes hidden underground on the moon. The moon does not have an atmosphere to provide protection, and its surface is constantly bombarded by cosmic radiation and micrometeorites. Unpredictable solar storms can engulf deadly radiation to the surface within minutes. Astronauts are like running naked in a CT scanner for 1 to 5 full-body scans every day. During the day, the surface temperature of the moon can soar to 121 degrees Celsius, and at night, the temperature drops sharply to a cold -129 degrees Celsius. These intense fluctuations, combined with sustained radiation, pose a deadly threat to both humans and machines. To survive and work here in the long term, it is necessary to overcome these enormous and life-threatening challenges. The interior of the lava tube provides a natural shelter, with thick basalt walls that can block radiation and meteorites. The internal temperature remains stable at 17 degrees Celsius, making it an ideal location for a lunar base. China plans to achieve manned lunar landing before 2030 and use these lava chambers as potential base sites to establish permanent lunar stations. The idea is to enclose these underground spaces and fill them with breathable air, using a few tens of meters thick basalt roof as a natural protection against radiation and micrometeoroids. The stable environment inside the pipeline allows astronauts to grow food on the surface, creating a self-sufficient colony. However, exploring these caves faces enormous challenges and requires dispatching robots for surveying first. For example, advanced devices such as NASA's X-O rover or Europe's DETR's spherical robot are currently under development, aimed at mapping the internal structure of caves and evaluating their safety. The most innovative method comes from the space jumper developed by a Swiss team, which pushes itself forward in low-gravity environments by bouncing on difficult terrain. It can jump into deep pits and caves, capture visual data, and effectively exit. If the lunar base is built inside these lava tubes collapse during a lunar earthquake, it would be a catastrophic disaster. China is also planning to use robots equipped with 3D imaging for detection. In addition, these caves may also contain valuable resources. Helium-3 can provide fuel for nuclear fusion reactors, with a storage capacity millions of times that of Earth, theoretically meeting global energy needs for thousands of years or even longer. It is also possible to find water ice, which can provide oxygen for respiration, hydrogen for rockets, reduce dependence on Earth's supply, and turn the moon into a launch pad, becoming a springboard for Mars and even farther planets. Moreover, validating closed ecosystems and long-term residency technologies on the moon can accumulate experience for Mars missions.